Hello, and welcome to the second episode of R in Finance. The agenda today is going to be, in the first step, actually looking at the RStudio interface. And then in the second step, we'll actually proceed to some basic operations in R already. I hope you have been able to download both R in RStudio and are now able to proceed with. What you can see now is the RStudio user interface. As you have maybe noticed already, the interface is divided in four main panes. If this is actually not the case for you, you have to advance to View, and then you actually go on Panes and press on Show All Panes. Now you should have the same setup as me. So we will start from the left corner window, which is our text editor. So if we, for example, type in 1 plus 2, this is already going to be our first basic operation. So if you type in 1 plus 2 and then you press Control Enter at the same time, you can see that in the top left corner, nothing happens. This is because this is purely a text editor. But what actually happened is that our console, which is on the bottom left corner, already produced an output. So as you can see, the first line is our input, which is 1 plus 2. And we already generated our output, which is 3, which is correct. Thank you, R. What we could actually also have done is we could have typed this in the console itself. And we would have gotten the same result. But the thing with the console is it's going to be very hard for a third person to reproduce your script. So I encourage you to always do it as a text or in the text editor and then save the text editor, because this will allow you to reproduce your code. Now we'll proceed to our third window, which is the top right corner. And you can see it says environment is empty. Your environment will save all different types of variables. And I'm going to show in a real simple example how it actually works. Oops, this is me working in the console. We don't want to do that. So if we want to assign a variable to z, for example, we're going to do z, and then we're going to do an arrow. You can also use an equal sign, but I really support the usage of the arrow. Is 1. So z is going to be 1 now. We press Control Enter, and as you can see, this variable is now stored into our environment. How is this useful? You can, for example, now call z, and it's going to give you back 1. Okay, so if we now advance to the bottom right corner, we can see we have different subcategories. So the files category actually shows you in which working directory you're working, and from this you can proceed further. The plots is actually just going to show you the plots you produced. So in the packages subcategory, you can actually see all the packages that have been loaded in. But as you may have noticed in R, not just because you download or install a package, it means that it's going to be immediately active. It's going to be your task to activate it. This is the help subcategory, which is going to be very, very helpful. And I will talk about this much more in depth in later videos. So these are the most important things we just went over. And now we are going to actually proceed to some very simple and basic R operations. I encourage everyone to do all the same operations as I do, because this is going to be how you learn. So let's start with this. Basic operations in R. Okay, so we will just start off with a very simple example, and maybe to just have a fresh sheet, we will just clean all our environments. Yes, thank you. So let's start off with a very simple operation, not in the console, but in the text editor. 1 plus 2 plus 3. This is obviously correct. 1 plus 2 plus 3 is going to equal 6. Let's proceed with 1 plus 2 plus, no, times 3. So this now is obviously a very much different equation, as we now have to respect the range or the priority of operations, where a multiple is going to be calculated first and then an addition. So in this case, we should already get a 7. Thank you. Now we even advance and add brackets to the operation we just have, doing 1 plus 2 in brackets times 3. R, obviously, I'm showing you this to show you that R obviously respects all these types of priorities. So 1 plus 2 equals 3 times 3 equals 9. So this is correct as well. As you can tell, the interactive R interpreter will automatically print an object return by an expression entered into the R console, which you can see here. Notice that there is a number before our actual number, which is the 1, and it has been there everywhere. Now you might be asking yourself, why is this? This is because in R, any number that you enter in the console is interpreted as a vector. A vector is an ordered collection of numbers. The 1 simply means that it is the first number in the vector, and thus it is the index. So we are actually going to advance a little bit further to show you what a vector is and how to set them up. So as I said before, a vector is just many numbers put together in a certain order. So we are now going to be setting up Fibonacci vector, which is nothing more than the first few numbers of the Fibonacci series. So let's start by pressing C, which means combine. This is how you actually set up a vector. And then we're going to enter the Fibonacci numbers, which are 0, 1. This depends on how you want to start your Fibonacci vector, but I'm going to start it like this. 2, 3, 5, 8. So I hope you have all followed up like this. And now we just press enter. So as you can see, this vector just simply holds the first 7 numbers of the Fibonacci series. If we, for example, would want to set up a vector with integers from 1 to 50, we could, for example, proceed like this. So setting up a vector of integers from 1 to 50. So to set up a vector like this, we could, for example, one of the many ways to do this is we could just simply type 1 and then double points and then 50. As you can see, the output in our console is every number going from 1 to 50 in steps of 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could also do this differently, and you might now notice a little difference. We could use, this is us using our first function. Sequence 1 to 50. What you can notice now is I don't use double points to define my vector, but I use a comma. And as you can see, I get the same output nonetheless. Maybe something you can also notice now is that we not only have a 1, but we also have a 32. And this number, in this case, indicates the index value we are at. So now this corresponds here. But if we, for example, change the sequence and go from 1 to 50, no, from 1 to 100, and we do it by 2 steps, you can actually see that now the index 32 holds the number 63. So next we will actually assign our sequence to a variable. So let's do this. We're just going to type in vector. Maybe we'll do it with vec start to be sure. And we assign it with the arrow. And then we can use any of the 2 methods. I will use 1 to 50 like this. And I will press Ctrl Enter. And as you can see now, it has been updated in our global environment. And you can see vec start, and you have just the vector. The vectors are very handy because you can also do operations on them. If I, for example, have a vector of let's say sequence, or let's keep the grammar the same. 1 to 4 plus let's do it like this, sequence 10 to 40 step 10. So what should the output now be? Let's see. What we have now here is we sum 1 plus 10 and then 2 plus 20. We do 3 plus 30 and then 40 plus 4. We could also have written this like this, for example. 1, 2, 3, 4 plus 10, 20, 30 and 40. This is going to give us the same output again. What you could also do, you could assign this addition of vectors to a variable, for example. What we could also do is we could assign this addition of vectors to a variable. So let's call this x, and then we just assign our addition to this variable. So now you have x. X is now going to be the vector of the output. But what happens if, for example, the vector operation you're trying to do, both vectors don't have the same length? So if we, for example, have 1 divided by, let's say, 1, 2, 3, 4. What is going to happen now? Let's press Control Enter. So what happens now is that if the vectors aren't the same size, R will repeat the smaller sequence multiple times. So the smaller sequence in this case is 1, and then 1 gets divided by 1, 2, 3, and 4, giving us the outputs we can see below. So, okay, let's show another example. We have 1, 2, 3, and 4, plus C. Let's do 10 and 100. What do you think will happen now? Because the second vector is still a multiple of the other, even though it is shorter. Let's see. 11, 102, 13, and 104. So what happened now is that the second vector looped through twice. So we had 10 plus 1, then we had 100 plus 2, then again we had 10 plus 3, and 100 plus 4. But if, for example, one vector is not a multiple of the other, we should be getting an error. So let's do this example again. And then we do plus C 10, 100, and 1,000. Yes, as you can see, the warning we get from the console is that the longer object is not the multiple of the shorter object. So all the operations we have done until now have all been numbers. But you can also save strings to a vector. First of all, I'm just going to print any kind of string into the console. As you can see, it gives back again hello world, and you can see that it is again indexed into a vector. So what happens if we do this, for example? I don't want to type into the console, thank you. So let's type in hello world, and then we add a comma and type in hello YouTube. What will this going to produce? And yes, it just gives back a vector of strings. So let's do this, string vec. And then again, we assign it to a variable. Okay, as you can see, we don't get an output, but then again, if we type string vector, we get the vector back. So in this episode, we just did some very basic R operations. And in the next video, we will focus further on, or we will start focusing on functions. I hope I see you in the next episode.